Hi, good day everyone. So today we're going to be doing January 2018, number 10, or in just the vectors and matrices questions, right? Let's look at the first question. They said, given that vector OP is 3, 4, PQ is -1, 2, RS is 1, 3, find out what is OQ. So that means the starting point is O, ending point is Q. So you want something that has O and Q, but something they have in common. So we can go, the ones that has Q in it is P. So we have to look for a vector that has O and P, right? And we can see it would be OP plus PQ would give you OQ. Right, so again, your starting point is the first value, Q is your ending, and then P's, that's the one closest to your plus sign, must be the same point in common. Right, what is OP? That's 3, 4, and PQ, right, is -1, 2. You're going to be adding these two. So it is 3 plus -1, not over. Right, that's the top, and then the bottom would be 4 plus 2. 3 plus -1 is 2, and 4 plus 2 is 6. So we know that OQ would be equals to 2, 6, and that is the question. That is the answer for the first part. Let's look at the second part. That's 2 marks right there. Show that OQ and is parallel to RS and give reason for your answer. Right, so if they are parallel, it's either they are the same or scalar vectors of each other. So if we look at OQ is equals to 216, right? Not 216, 26, sorry. It's 26. And RS is equal to, what is RS equal to? 1, 3. Here, we have to compare them. So if we compare OQ to RS, 2 multiplied by what would give you, no, I always say compare the smaller ones to the bigger ones, right? So RS is 1 multiplied by what would give you 2, and then 3 multiplied by what would give you 6. Always compare the smaller ones to the bigger ones, so you would not have to deal with fractions, right? So 2 by what would give you 1? 2 by 2, sorry, 1 by 2, and 6 by 3 by what would give you 6? 2, right? Or you could have made the boxy subject by carrying across, multiply by 1 here. So you have said it's 2 divided by 1 is 2. And this one you carry across, multiply by 3, which is divided by 3, which is equals to also 2. You could have done that, right? So we can see that 2RS is equals to OQ. Or if we wanted to compare it with OQ, it would be a half OQ is equals to 1RS. So because of that, they said give reason for your answer. So yes, you can show this working, but you need to say that RS is a scalar multiple of OQ. So RS is a scalar multiple of OQ, therefore RS and OQ are parallel. That's the sign for parallel. You could just write the word parallel to each other, right? So if they are equal, they are parallel. And if they are scalar multiples of each other, they are parallel. Those are just the notes to remember when things are parallel to each other. All right, let's go to the next question, part B. They said triangle XYZ and M. There's a triangle XYZ, right? M is the midpoint of ZXZ. XY is equals to A and XZ is equals to B. Now, what I would recommend in this question, and it's just, they didn't tell you to do it, but just visually, let's draw a triangle. It does not have to be, and let's label it X, Y, and Z. It's just for you to visually see, right? I put these sides all equally. Don't do that because we don't know what sides are equal and what sides are just visually for you to see. They said XZ is the midpoint. So M is right here, the midpoint there. They said that XY, so going from X to Y is A, and going from Y to Z is B. So it's just for you to see, right? They want to know what is XZ. So that means our starting point is X, right? Our ending point is Z. And looking at the image here, you can clearly see that using the arrows, let's see, we start at X, we go to Z, right? And then you go to Y, and then you go from Y to Z, right? So you see when you draw the triangle, you could clearly see what is the point in common, which is Y, right? So that would be XY plus YZ would give you XZ, right? What is XY? XY is A. What is YZ? YZ is B. So we know that XZ is A plus B, right? Very simple. Y, MY. So if we're looking at this, we want MY. So again, there are two ways to do this. I will start with Y to Z and Z to X. Now, because they said this little point here, M is the midpoint of XZ. We know what is XZ. Therefore, XM, let's just put M here, is equals to MZ. Yeah? And XM and XZ would be equal to a half of XZ, which is a half of A plus B, which is a half A plus a half B. All right? So you know that XM, if you want to go with the starting from X to, don't do that. Start from Y, because the axis MY, right? So now the starting point is M, ending point is Y, right? So you can either go from M to X and then X to Z. Let's use a dotted line for you guys to see. M to X, right? And then X to Z. You can go this direction here, right? The dotted lines, or I'll just change the color, the blue here. Or you can go in the opposite direction, that's M to Z here. Let's use a different color. Let's use green. And then Z to Y. Right? Because, so whichever direction you're going to choose, we know that you're going to get the same answer. Well, you should get the same answer. So I'm going to go in the direction of M to X and X to Y, right? So my common point in common would be X. We know XM is equal to a half A plus a half B. But we want MX. MX is going in the opposite direction. So you multiply a half A plus a half B multiplied by -1. So that's negative a half A minus a half B. Right? So let's write that, a negative a half A minus a half B plus, what is XY? XY is, they said in the question, XY is A. So you simply add A to it. Right? So this would be minus a half A plus A minus a half B. A minus a half A or minus a half A plus A is equal to a half A minus a half B. This is, right? And that would be, well, you could factorize the halves out because they have that in common. That's a half open bracket, A minus B, and that would be your answer. So this is the answer for this question. If you wanted to go the X route, now let's just say you wanted to go the Z route. I'll put it in green so you could so you guys could see. If we wanted to go the Z route, that's MZ plus ZY, right? So that would be MZ plus ZY. Starting point is M, ending point is Y, points in common Z. We know that MZ from above here is a half A plus a half B, right? That's a half A plus a half B. And then we know ZY is, we know what is YZ, right? YZ is equals to B, but we don't want YZ, we want ZY. Right? So ZY, which is going in the opposite direction, because they're going in the opposite direction of each other, you simply multiply the B by -1. So that's negative B. So that would be a half A plus a half B minus B. So we have a half A and a half B minus B is equal to minus a half B. And we can see that this answer and this answer is the same. So it does not matter the order in which you choose to go it. Just know that the answer is, and well, you factorize out a half. That's a half, open bracket, A minus B. So that is your answer for what M1 is equal to. Okay, now they said the matrix A and B is given. A is -1, 0, 3, 2. B is 2 minus 3, 2, 1, 1, 4, 6. The first thing I like to do is put the orders of the matrix. This is 2 rows by 2 columns, and this is 1, 2, 3 rows by 2 columns. Right? They said find the inverse of A, or A inverse, or determine A inverse. We know that the formula for A inverse is 1 over AD minus BC multiplied by D by minus B minus C, which is 1 over, this is the same thing as saying 1 over the modulus of A, which is AD minus BC multiplied by A adjoint. And what A adjoint is equal to, you exchange or interchange the positions of A and B, sorry, A and D, and then multiply B and C by -1. So, as we know, our matrix, 2 by 2 matrix is always A, B, C, D. So now let's just put in the values, right? That's 1 over, what is AD? That's -1 multiplied by 2, put that in brackets, minus BC, which is 0 multiplied by 3, right? Multiply by interchange A and D, that's 2 and -1, and then multiply 0 and 3 by negative. There's nothing like -0, so you'll put 0, and then 3 by -1 is -3. Right? And then after you do this, this would be 1 over -2 minus, well, I think multiply by 0 is 0. So it's 1 over -2 or -1/2 multiplied by 2, 0 minus 3 minus 1. And when we have things like this, a half is just a scalar multiple of what we're trying to find out, right? What that means is you'd simply multiply a half by each term, or minus a half. So this would be -1/2 by 2, then -1/2 by 0, then -1/2 by -3, and then -1/2 by -1. Right, put this in brackets here. A half by, always do the numbers first, right? A half by 2 is 1, and then minus, and a plus is a minus, is -1. Anything by 0 is 0. A half by 3 is 3 over 2. A minus is a plus, so this is plus 3 over 2. And then a half by -1, that's a half by 1 is a half, and a minus is a plus. So your answer for this would be, well, if you break it down, would be -1, 0, 3 over 2, and a half. Right? And that is how you would do this question right here. You just need to remember this formula. So this formula is the most important formula when you have to learn to do the inverse or even anything. Right? Show that, you have to show it, okay. Show that A inverse by A is equals to identity. Now, we have to recall that an identity matrix is always in the form of 1, 0, 0, 1. So that means we have to multiply this by vector A to get this. So A inverse is -1, 0, 3 over 2, 1 over 2, multiplied by A, which is -1, 0, 3, 2. And we're going to first, again, when you're multiplying, you just make sure that they are compatible to multiplication. This is a 2 by 2, this is a 2 by 2, right? The number of columns in your first matrix and the number of rows in your second matrix are equal, so they are conformable to multiplication, and your resultant matrix is going to be a 2 by 2, right? So that means we have element row 1 by column 1, element row 1 by column 2, element row 2 by column 1, and element row 2 by column 2, right? This is just not the easier way. It's just so that you will be able to understand. However, we can do it, right? So first off, we're going to, it's your first row by a first column. So it's -1 multiplied by -1 plus 0 multiplied by 3. That is your first one by a first column. And then it's your first row by a second column. So that's -1 multiplied by 0 plus 0 multiplied by 2. That's this here, element 1, 2, which is your first row by a second column. And the bottom is 3 over 2. Your 3 over 2 multiplied by your second row by a first column, which is multiplied by -1, plus a half multiplied by 3, right? And then this one is 3 over 2 multiplied by 0 plus a half multiplied by 2, right? So minus and a minus is a plus, so that's 1, and well, 0 by 3, so this is +1 plus 0, and then this is minus, hold on. Anything by 0 is 0, so this is 0 plus 0, which is 0, right? And then it's 3 2 by -1 is -3 over 2 plus 3 over 2, which is 0. These cancel off each other. 3 over 2 by 0 is 0. A half by 2 is +1. So when you add them all up, 1 plus 0 is 1. 0 plus 0 is 0. Minus 3 over 2 plus 3 over 2 is 0. And then plus 1 is 1. So we can see when you multiply the inverse, and this is just a known thing, okay? When you multiply the inverse by the matrix of that inverse, you're going to get the identity matrix of 1, 0, 0, 1. Use. All right, determine a matrix A squared. What does A squared mean to do? It's A multiplied by A. All right? So A squared is A multiplied by A, right? Not A and you say to the power 20, you find these, don't do that, right? This is A multiplied by A, all right? So what we're going to do is we have to recall that A from above, A was equal to -1, 0, 3, 2. So you're going to multiply -1, 0, 3, 2 by -1, 0, 3, 2. Right, so again, first things first, make sure that they're conformal to multiplication. This is a 2 by 2 matrix. This is a 2 by 2 matrix. The number of columns in your first matrix and the number of rows in your second matrix are equal, and your resultant matrix would be the number of rows in your first matrix multiplied by columns in your second matrix, which is also a 2 by 2. Right, this would be 4 elements: 1, 2, 3, 4. This is element 1, 1, 2, no, 1, 2, 2, 1, and 2, 2. All right, so we're going to find element 1, 1. Element 1, 1 just means you're multiplying the first row by the first column, so that's minus 1 multiplied by minus 1 plus 0 multiplied by 3. All right, then your first row by a second column, that's E1, 2, that's minus 1 multiplied by 0 plus 0 multiplied by 2. All right, and then E2, 1 is your second row by your first column, 3 multiplied by minus 1 plus 2 multiplied by 3 by minus 1 and 2 by 3. All right, and then this one is 3 multiplied, right, your second row by a second column. So this by A. All right, so it's 3 by 0 plus 2 by 2. All right, and then we just add up minus and a minus and a plus. That's 1 plus 0. Then anything multiplied by 0 is 0. So this is going to be 0. Minus 1 by 0 is 0. Plus 0 by 2 is 0. So the final answer there is 0. Right? Right, and then 3 by 1, minus 1 is minus 3. Plus 2 3s are 6. Then 3 by 0 is 0. 2 by 2 is 4. So this would equal 1 plus 0 is 1, then 0. Minus 3 plus 6 is 3, and 0 plus 4 is 4. So A squared would be equal to 1034, and that is the answer for this question. Explain why matrix A, the matrix of the product of AB, is not possible. So let's recall, and I have been saying this all through the video, right? A was a 2 by 2 matrix, and B, if I'm not mistaken, was it a 3 by 2? Hold on, let me just make sure. So when we were doing, right, B is 3 by 2. So if you had to multiply A by B, remember I always say if they're conformable or not, right? So this is 3 by 2. You always make sure that the number of rows in your the number of columns in your first matrix and number of rows in your second matrix are equal. They are not equal, so therefore they are not conformable or not possible to multiply. So that is exactly what you see. The number of columns in matrix A is equal to 2, and the number of columns in matrix A and number of rows in matrix B is equal to 3. So 2 is not equal to 3, hence they cannot multiply. Right? Or not conformal to multiplication. Or you could simply say the number of rows in the number of columns in your first matrix is not equal to the number of rows in your second matrix. Hence, they cannot multiply. Without calculating, state the order of BA. Now, if I have to multiply B by A can multiply because this is a 3 by 2 and this is a 2 by 2. So we see the number of columns in our first matrix is equal to the number of rows in our second matrix. So we can multiply. And I told you guys the order of our answer when we multiply it is the number of rows in your first matrix multiplied by the number of columns in your second matrix. So this would be a 3 by matrix if you multiply B by A without multiplying it, right? And that would be the answers for, this would be the answers for January 2018, the matrices and vectors question.